Afternoon, my good people. I want to wrap up this week. Today is a Sunday by a tutorial in mathematics. And the tutorial is about approximation and errors. By the end of the lesson, learners should be able to define approximation and explain why it is used, round off numbers to a given number of decimal places or significant figures, state and calculate errors, including absolute error, percentage error, determine upper and lower bounds of rounded values, apply approximation and error concepts in real-life situations, such as measurements and estimation, and finally, the learners should assess the accuracy and reliability of approximate values. Note that the learners might be you people of the internet. In everyday life, we rarely use exact values. We estimate distances, round off money, approximate measurements, and make quick calculations to save time. In mathematics, this process is called approximation. However, approximations may differ from the true or actual value, leading to what we call errors. Understanding approximation and errors helps learners judge how accurate a value is and decide whether an estimate is acceptable in real-life situations such as measurements, budgeting, constructions, and science experiments. Approximation. Approximation is the process of replacing a number with a value that is close to it but is simpler to use. Common methods of approximation are rounding off, truncation or cutting off digits, using significant figures, and using decimal places. For example, pi is approximately 3.14 to 2 decimal places. 1/7 is equal to 0.14 to 2 decimal places. 23.678 rounded to 2 decimal places is 23.68. Rounding off rules. Look at the digit after the required place value. If it is 5 or more, increase the previous digit by 1. If it is less than 5, leave the previous digit unchanged. Example, round 6.3482 decimal places. The third decimal place is 8, and 8 is greater than 5. Therefore, the answer is 6.35 when you round up. Meaning of truncation. Truncation is a method of approximation where digits after a certain point are simply cut off without rounding up or down. Key idea is no consideration of the next digit. And the next key idea is that the number always becomes smaller or stays the same. Examples: truncate 7.689 to 2 decimal places gives you 7.68. You just cut off 9. Truncate 0.4567 to 3 significant figures. 0.456, you cut off 7. Continuation of truncation. Characteristics: easy and quick method, less accurate than rounding, often used when overestimation must be avoided, common use, financial estimates, measurements where excess must be avoided. Using significant figures. What are significant figures? Significant figures are digits in a number that contribute to its accuracy, starting from the first non-zero digit, meaning 0 is not significant unless it obeys the following. Rules for significant figures. All non-zero digits are significant. Number 2, zeros between non-zero digits are significant. 3, leading zeros are not significant. 4, trailing zeros are significant only if a decimal point is present. Significant figures continued. Rounding to significant figures. Identify the required number of significant figures. Look at the next digit. If it is greater than 5, you round up. If it is less than 5, leave unchanged. For example, 0.004678 to 2 significant figures is 0.0047. Again, 56,349 to 3 significant figures is 56,300. And 9.995 to 3 significant figures is 10.0. Common use: scientific measurements, physics, chemistry, and biology, and calculations involving accuracy. Using decimal places, meaning of a decimal place. Decimal place refer to the number of digits after the decimal point. Rounding to decimal places. Count digits after the decimal point. Check the next digits. If it is greater than 5, round up. If it's less than 5, leave unchanged. Examples: 12.6784 to 2 decimal places is 12.68 because the next digit is greater than 5. We round up and the 7 becomes 8. 0.54321 to 3 decimal places, 0.543. So we just leave this unchanged because the next digit is 2 and it is less than 5. 9.995 to 2 decimal places is 10.00. All right, in this case, 0 after 1 is significant, but the other two zeros are not significant. Characteristics of decimal places. It focuses only on digits after the decimal. Next, easier than significant figures. And again, it is widely used in everyday calculations. Common use: money, e.g., Kenya shillings 125.50 to 2 decimal places. Length, mass, temperature, and examination answers in mathematics. So here, our quick comparison table, where I have method, main focus, and accuracy. I start with truncation. Main focus is cutting off digits. Accuracy, least accurate. Significant figures. Main focus is overall number size. Accuracy, high accuracy. And decimal places, main focus is digits after decimal. Accuracy, moderate accuracy. You cannot do approximations without looking at errors. So, what is an error? An error is the difference between the exact or true value and the approximate value. That is, error equals exact value minus approximate value. Errors can be positive or negative, but we often use the absolute value of the error. Types of errors. A. Absolute error is the magnitude of the difference between the exact value and the absolute value, the approximate value, sorry. And here, magnitude means the size or amount of something without considering its direction. In fact, the magnitude of a number refers to its absolute value. For example, the magnitude of -5 and +5 is 5. That is, the absolute value is a number without the sign. B. Absolute error is equal to exact value minus approximate value. Example. Exact value is 5.72 and approximate value is 5.7. So the absolute error will be the difference, which is 5.72 minus 5.7, which is equal to 0.02. Relative error. Relative error compares the absolute error with the exact value, and it is given by absolute error over exact value. The third type of error is percentage error, which shows the error as a percentage of the true value, and therefore it is given by absolute value over exact value times 100%. For example, exact value is equal to 0.142857. Approximate value equals 0.14. Therefore, absolute error is 0.002857 when you find the difference. And hence, the percentage error is the absolute error over the exact value times 100%, that is 0.002857 over 0.142857, and the answer is going to be 2%. Maximum error. When a number is rounded to a given accuracy, the maximum possible error is half of the smallest unit used. Example, rounded to nearest whole number implies maximum error is 0.5. Rounded to one decimal place implies maximum error is 0.05, and when you round it to two decimal places, maximum error is equal to 0.0057. We come now to another area on approximations, that is upper and lower bounds. When a number is rounded, the true value lies within a certain range. The lower bound of the range is the smallest possible value, which is equal to approximate value minus maximum error. And the upper bound, the largest possible value, is equal to approximate value plus maximum error. Example, length is given as 12.4 centimeters correct to one decimal place. Therefore, the maximum error is 0.05 centimeters. Lower bound is 12.35 centimeters. You subtract 0.05 from 12.4, and upper bound is 12.457, where you subtract 12. You add 0.05 to 12.4. The true length lies between 12.35 centimeters and 12.45 centimeters. Importance of errors in real life is measuring cloth, measuring wood, or measuring land. It can also be used in engineering and construction. Again, science experiments like physics, biology and chemistry, finance and budgeting. Small errors can lead to bigger mistakes or big mistakes, so accuracy is important. Now, let's take an example of a KCSE or a Kenyan mathematics final examination question. A tailor intended to subdivide a piece of cloth into 7 equal parts. He approximated 1/7 meters to 0.14. Calculate the percentage error in the approximation. The exact value of 1/7 meters is 0.142857 meters. The tailor approximated it to 0.14 meters. So let's proceed. Step 1, find the absolute value. Error is equal to exact value minus approximate value, which is 0.142857 minus 0.14 gives you 0.002857. Step 2, percentage error formula. Percentage error is equal to error over exact value times 100%. So substitute the values. 0.002857 over 0.142857 times 100%. Since 0.142857 equals 1.7 and 0.00287 is approximately 1/350, this is equal to 1/50 over 1/7 times 100%, which simplifies to 7/50 times 100%, And this becomes 0.02 times 100%, which is 2%. Therefore, the final answer, the percentage error in the approximation is 2%. Key summary. Approximation simplifies calculations. Error equals difference between exact and approximate values. Percentage error shows how significant the error is. Maximum error depends on the degree of rounding. Always state the level of accuracy used when approximating value. Truncation involves cutting off digits without rounding. Significant figures show how accurate a number is. Decimal places focus on digits after the decimal point. Errors help us measure accuracy. Bounds show the range in which the true value lies. Remember, the smaller the error, the more accurate the approximation. In conclusion, approximation and errors are essential mathematical concepts that connect mathematics to real-world applications. Since exact values are not always possible or practical, learning how to approximate correctly and measure the resulting error allows us to make informed decisions. A good understanding of errors helps us judge accuracy, improve precision, and avoid misleading conclusions.